Slope-intercept form of a line. During the bowling ball lab, which hopefully you did, we calculated the slope of a distance time graph to find the speed of the bowling ball. And we found that the slope of the line was rise over run, y2 minus y1, over x2 minus x1. As a first step for our new analysis, we'll just name the coordinates for the second point xy rather than x2 and y2. That will be true for any point on the line, not just one point, and it'll allow us to write an equation for all points on the line. So our slope formula is now just y minus y1 over x minus x1. Let's solve this equation here for y using what we've learned about solving equations. Try it yourself before we show you the answer. Here's a hint. Treat the denominator, the x minus x1, like it's in parentheses. Multiply both sides of this equation by parentheses x minus x1. That will get rid of the fraction because it will cancel out this term and then show up here on the left side. Now add y1 to both sides. That moves y1 over to the other side with the opposite sign. It's now a plus. Now switch the sides. So we have an equation for y. This is fine. It allows us to graph a line given any point x1, y1. But we need one more additional step to get the most useful equation for a line. We will let this term here, this x1, we'll let x1 equal 0. That will yield us the y-intercept for x1, y1 is equal to 0, comma y1. See, we've replaced the x1 with 0. So let's look what that looks like on a graph. Here's x, here's y. If x is 0, plotting 0, y1 will be over here. That's 0, y1. We call that the y-intercept. That's the point where the line, let's say we have a line like this, that's where it crosses the y-axis. The coordinates of that point we're going to call 0, comma b. So what do we have? X is 0 anywhere on the y-axis. The y-intercept we're going to call b now instead of y1, and the whole equation becomes y is equal to mx plus b. We call this the slope-intercept form of a line. Y is equal to mx plus b. M is the slope, b is the y-intercept where the point is 0, comma b, and it crosses the y-axis, and x and y are any of the infinite points that satisfy the equation. This is the form of the equation of a line that is most often used. If you have a graph of a line, you can calculate m and read b directly from the graph. You would find m from the slope, which is rise over run, and you can find b just by looking at where does the line intersect the y-axis. So you can write the equation of the line directly, which you can then use to find any other needed points on that line. The line shown in the coordinate plane to the right has a y-intercept at the point 0, minus 2, that is right there on the y-axis, this point right here, and it has a slope of 2 over 3 or 2/3. Therefore, the equation of the line, it's y is equal to mx plus b. The y-intercept is b, so that's negative 2, and the slope is 2/3, which is m. And you can see the slope, which is rise over run, or delta y over delta x. It goes up 2 and goes to the right 3, so the slope would be change in y is 2, change in x is 3. So the slope is 2/3, and the equation of the line is y equals 2/3 x minus 2. Here's an example for you to work. Write the equation for the line shown on the graph to the right. Here's your line. I'm showing both endpoints. First, what is the slope of the line? And then find the y-intercept of the line, and then write the entire equation. So pause the video if need be, and move on when you have the answers. To find the slope, we'd like to find points on the green line that lie on the intersection of our graph, something like that. So where can we find one? Here's a point right here, okay, and that point is negative 4, comma 7. Now let's find a second point. Let's see, negative 2, right over here, okay, that is negative 2, comma 3. So to find the slope, we use delta y over delta x. So that would be 7 minus 3, which is 4. The negative 4 minus a minus 2, that will be minus 2. So our slope is negative 2. We see that the graph intersects the y-axis at negative 1, and that of course is our b value. So the equation of the line in slope-intercept form is y equals mx plus b. Our m is negative 2, and our b is negative 1. Let's work another example. We have the line over here, and I'd like you to find the slope, which is m, the y-intercept, which is b, and then write the equation of the line in slope-intercept form. And pause the video if needed, and move to the next slide when you have an answer. In this case, the slope of the line is 0, because y never changes. We always have a constant y here, so at any point, y minus y1 will be 0. So the slope is 0. It intercepts the y-axis at b equals 2. b is our y-intercept. So we then write the equation. It's y equals mx plus b, 0x plus 2, and we don't have to keep the 0x, and we just write the equation as y equals 2.